Hello again. So basically, I'm working on the wiring of the Voron 350 by 350 Voron 2.4, and this is the wiring for part one. I just go overview if you feel anything you can get from my video, that's good for you, right? Anything you know already from other video like Nero, for example, good to go too. So it's the reason why I make the video, because depending on the build, and sometimes it may vary a little bit. For my example, I prefer to build this way, the other person maybe prefer to build the other way. So basically, we have a power supply. Remember, like, to cut off the power supply before you do any you touch into the electronic, because you don't know if like you touch in and then maybe there's a metal, it's maybe do a short circuit. Anyway, basically, overview is, you have a switch, you have a ground, you have the left side will be the hot wire, letter L, right? The right side will be the neutral one, and then from there you come to the switch. This is a switch. Basically, it acts as a bridge to break up the power, right? This is the neutral one. The one inside come from the hot wire, get into the brown wire in hot wire. The neutral one get into the blue one, the neutral one. So basically, I design this one by myself based on the other people design, and I imitate and then change a little bit so it fit into like the other one, and then it can have a larger surface contact area to make a bigger stripe of 3M glue, the VSP glue, VSP tape. So basically, I decided to choose this one at the ground, play this one at the hot wire, the last one will be at the neutral one. Okay, so you can see, basically I come from the ground, I come to the wiring of the ground of this one. See, another wire you can see on here on the bottom, E actually is the grounding of. I try to put it into the screw of the DIN rail, in order to ground the whole thing. So basically, if I use this thing to test, basically if I turn here, it will have the current down here. So basically they connect together. I can measure the ohm, the resistance between the plate. Except for this one, they do have the connection to the ground, but except for the painting on the surface, it prevents the electric current. But I try to strap it a little bit, test it. The aluminum inside do have the grounding, but only because this is two aluminum plate and plastic between. So yeah, maybe if the screw is not come all the way through, then it's only grounding the underplate. I'm not sure, I'm not testing the front, the top, but I testing on the bottom. I see it's ground already. This two DIN rail ground already. The build plate ground already. So because the build plate it's separate by the frame. So the frame have some paint in there, so have painting in there, have black paint in there, and that's black paint prevent the crowding, the grounding. Anyway, The next thing I like to say is to see just either the hot wire, right, going to either one of the hot terminal 120. I use the Panasonic make from Japan instead of the China's quality. I don't trust China quality on safety, especially on this relay. This solenoid inside this the magnet inside may stuck in there forever and then keep hitting up. I don't want to blow my fuse. I don't want to change the fuse. It's a pain, right? You have to take off the whole aluminum plate and then put it on a new fuse. But yeah, instead that you try to use the high quality relay, so it may last for 100 hours printing, 1,000 hours printing. It still fail. It's similar like the solenoid of the irrigation. You do need to change it. It worked for a while. Yeah, I tried to link this one to the hot wire of this one test it at 5.8. They have a knob to adjust the voltage. Is 5.1. I put it 5.1. The maximum I think Raspberry Pi accept you 5.14, I believe, 5.12, 5.14, but I put it 5.1, so less current get into the Raspberry Pi, because I don't this is the USB charging cable from who? From Samsung. I took out from the box. This is the flow case. So I try to strip about this one. If you want to connect this, you strip the USB-C cable out. You look for first, the red one will be the voltage one, and you can see there are three tiny bare aluminum, bare copper, I believe, copper plate. It's 3Y. That 3Y act as a grounding. You have to cut off the aluminum sheet surrounding the one to block the EMF. I think block the magnetic field. I think the interference. Yeah. So you only use the 3Y inside, right? Twist them together. That's become your black wire, and then put in the heat shrink tube. That's become your black wire. The red wire is just put it in to the red. You see, put a wago in here for the red. This black wire in here is the red one. The YY is the negative one. So the plus, the positive, the negative. I'm sorry. Anyway, the black go to negative, the positive go this way. It's come here and here, and it's powered up. It's all turning on already. I tested before I make the video. I just make sure the one of the terminal is connecting to your bed, and I use this one in 20 gal. It's look like them because it's a PTFE. So it's supposed to sustain over 200 Celsius, and because you don't use PVC close to the bed, it's heat up 80 degrees. It's melting ready. So 70 degrees maximum PVC. This one the same at your drain pipe, your water drain pipe. You don't put hot water into your drain pipe, right? It's melting the water, and it's costly. Many $1,000s to repair. Anyway, just the same thing. I put PTV and silicon. The Y one connect into the neutral, and the on the heat plate is too white wire, right? You can change the color whatever you want, but this is the one connect to the fuse, so I make it become black. From white I turn it to black. The other one I keep it like white, so I name it at neutral. Connect to neutral blue. This one connect. The reason I have this one, so it can organize, and when you need to replace something, take it out, replace it. That's it, right? And then it's easier for you to cut the length of the wire, instead of like you have to measure this one go to this one go to this. It's complicated, and then when it complicates, it get up batten down, it can hit into the terminal, right? That's what you don't want. Hit into the terminal, it's dangerous. So later on I put some glue in here, for example. Put a little bit glue in here. There is the insulator in here. I try to fit all the insulator, 2-layer of insulator actually, for more safety. This you have a thick clear insulator in here. See, that's the hot one, the L, letter L, hot one. This is the letter N, neutral one. See, that's it. I think I put the hot glue in there. For the screen, I just connected. So here I put some aluminum tape to prevent the EMF, prevent electromagnetic. Just a copper is better than aluminum, but I don't want any. I don't want to use copper because it's hand in there. See, I later want to tape it on the side. I have to manage it from. I don't want it tucked into no pin, right? Dentures, right? That's it. And then at the end of this one, I put a little bit of EMF because it's sharp in here. You know, I try to route it, the wire in here, and the other one too. I have to put it too later on. This one I leave it close to the fan, cooling. This one I don't want this one broken. This one, the good stuff. Mean well, I want to protect it. It doesn't have a fan in there. See, it doesn't have a fan. You put a fan in there. The fan in this doesn't have a lot of hole, but maybe it can try to go over the surface. And then the next one, the cooling, is the relay. There's a motor in there, solenoid, something like that. It's you like for the electric magnetic right field to pull and stuff together. So need to cool into this is the last thing you need to cool because it doesn't use much power anyway. This is output only like maximum 3 amp. I only use it for this one. I don't use it for anything else. Like no LED. LED is 24 volt. I bought everything is on 24 volt. So this here have a look. Next to this one, 3 of them. This here I leave it like 5 volt over this side, 24 volt, and then you can see the light right here. All high voltage in here. High voltage. This is high voltage. This one I cannot separate it. I don't want to separate. It make the wire longer. The longer the wire, the harder it is. So I don't want it. I want to leave it like that. Shorter, and they say I don't put like the positive terminal together because it's not together. See, this is the ground, neutral, and hot. This is hot only, just a bridge. This is hot, neutral, right? So leave it close as possible to this area so you can manage this one and try to like later on. I try to wire go all the wire. I try to go like go close as possible to parameters and go over this one, parameter go over this one, and then come finally, and then the other one I can go in here. So when I go in here, you see it's safe because now it become like all the area in here become like DC, no more high voltage anymore. See, it's clear. And this one connect to this one is very close. See, very close. You don't need to go the wire around. That's my personal thing, my personal thought. Maybe it's not the best, you know, but you know, at least it's I try to put more safety. For example, put some heat gun glue in the terminal right here. This one maybe nickel cap or something like that. This one, if you want better, nickel cap. Otherwise, you don't need anything. Just like, you know, have a thermal tape, the yellow tape, the captain tape. Put it over it. The captain tape is made on acrylic. This can last like over like 100 degrees. So captain tape in here is fine too. Captain tape is fine. Captain tape everywhere. Anyway, the thing I worry about this one, I don't want to tuck into the terminal. And if I see any problem occur, I may go into change it later on the configuration, the thing. But that's it for the it's a long video because it's a review about the safety and tip. Thanks for watching. Bye.